Hello, everybody. Can you hear me at the back? You can? Great. So we have an amazing panel today, and I'm joined by four of my colleagues from the industry. We'll start with Siggi Oskarsson from BSV. Then we have Jordan Kramsky from AWS, followed by Behrad Babaee from Aerospike, and finally Benjamin Kraner from the University of Zurich. So, thank you for coming to this session, and in the next 45 minutes we are going to go through Teranode and BSV in the enterprise. Now, for those of us in the blockchain space, there has always been this sort of debate from the very beginning, is that the blockchain is, and in the applications of the blockchain, particularly on the cryptocurrency side, are they meant for individual peer-to-peer decentralized applications? Are they meant for disrupting organized industry in a certain sense, and especially in finance? But in recent years, it's been pretty clear that the enterprise space is actually one of the places that is the hottest in terms of adoption for blockchain, and not just for the currency and the financial perspectives, but also for a range of other applications, right? And we know that there are issues around this. There are issues because when it comes to enterprise and blockchain, you've got to think about scaling that, and you've got to think about resilience and security and all these other things that no matter which blockchain you're using, you eventually run up against them, and then you go on to L2s and L3s and EVMs and all the rest of it. But today's panel, we're going to talk about the BSV blockchain and Teranode in particular, and how that tries to address this very key issue, which is absolutely essential to enterprises adopting blockchain for the long run, rather than just treating it as a pilot project or as initial things that they never really scaled on. And if anybody believes that this is a blockchain adoption in industry is unstoppable, just think about EVs. What's the story in 2024? People are not buying EVs anymore, right? Who saw that coming? So blockchain has a lot of things to solve from an enterprise perspective, or for enterprises, and today we're going to dive right in. So this eminent panel we have here, I'm going to first let them introduce themselves. We'll start with you, Siggi.
Hi, my name is Siggi Oskarsson. I'm the director of the Teranode project. And we've been working for quite some time to realize this vision that you talked about, was scalable blockchain.
Brilliant. Jordan.
Yeah, hi, my name is Jordan Kramsky. I'm a solutions architect at Amazon Web Services. I've been supporting the Teranode project for about a year and a half now, helping with the deployment and the architecture and everything else involved with it. So excited to be here today. Thanks.
Behrad.
Hi everybody, my name is Behrad Babaee. I've worked for a company called Aerospike. Aerospike is a database company. My skill set is building scalable, highly available and resilient systems. I'm not a crypto person, but as this project is using our technology, I'm here to answer some of the questions about the technology building blocks.
And finally, somebody not in industry, Benjamin.
So, thank you. I'm from the University of Zurich. I'm a PhD candidate there, and my research is mainly concerned around incentive systems in blockchains or in distributed acyclic graphs. Yeah.
Fantastic. Let's dive right in. Siggi, as the person who's essentially behind the Teranode project and has been leading the charge for some time, could you please explain to us why Teranode and why is BSV building that? What's the essence of all of this?
Well, if as a business you want to do anything that's meaningful, we all talk about scale.
Yeah.
Right. The scale. So a blockchain is basically just a timestamp server. So you're going to be using that for something else. You're going to use it for your business needs. So you're building this business that's not directly a blockchain business, but a different type of business that uses the blockchain. So you need a blockchain that scales. And this was talked about in the beginning by Satoshi in 2009, 2010, about blockchain ending up in server farms and having it scale. And we're just working on realizing that vision. We're adhering to the Bitcoin protocol, so we're basically creating a UTXO-based Bitcoin protocol adhering blockchain, but that scales unboundedly. That's our vision.
Right. It's great that you mentioned the Bitcoin protocol. I want to let you bring it up, because of course we all know that in the crypto world, there's been a fork a few years ago. A young, brilliant young man, Mr. Buterin, Vitalik Buterin, came up with Ethereum and said, "Hey, one thing that Bitcoin can't really do is do DApps or decentralized apps, and you can't build a programmable platform on it," to be challenged, of course. And so he said, "Well, let's do something different." And ultimately, the Ethereum now represents the proof of stake approach, which is obviously different from the original proof of work approach that Satoshi advocated and that the Bitcoin protocol is built on. So what's your take on that, particularly in terms of enterprise? As a corporate leader, you would look at it and say, proof of work, proof of stake, how does that impact me?
I think the adagium of proof of work can be found anywhere in business. If you're building a business, you're working very hard. You're doing the proof of work. You build a successful business. That's proof of work. The same thing is and you do that. You don't get anything given. You have to work for it. And I think that's the same thing in a blockchain. If you want an honest blockchain, you need to have that proof of work in there to make sure that all the participants are competing at a continuous pace and trying to outcompete each other and are trying to get better and better and better. In a proof of stake system, you have something akin to a monopoly situation more. You have parties that have a lot of coins, they stake them, and they earn more coins, so they're just getting bigger and bigger and bigger. So it's very difficult for an incumbent to come in and challenge that. So the proof of stake system, in the long run, keeps the whole system honest.
Right.
That's it, yeah.
So I'm assuming that the audience is fairly technically aware now that we are a few years into the blockchain space. And when we talk about these kinds of things, proof of work, proof of stake, and as you were just mentioning, the level of honesty that we require at some stage, Teranode and BSV is now utilizing Aerospike's technology. It's one of the fundamental building blocks. So Behrad, my understanding of Aerospike is that it's all about the efficiency, right? It's the reason why you don't need an L2, because it can get you that efficiency. So can you tell us a little bit about how the latency, first of all, why do we need that efficiency? Why do we need L2s? Why is that latency so critical for any peer-to-peer system, and especially those that are used in the enterprise space?
That's a very good question. So, we in Aerospike quite happy with this engagement that we have with Blockchain Association, with BSV, and the thing that they are trying to build. The Teranode project, in our view, is very important because it offers a unique solution to an engineering problem that doesn't necessarily have any effective answer in the industry at the moment. And basically that problem is a scalable, like a core banking system. Something like that doesn't necessarily exist, or if it exists, it's not really effective. So most of the banking systems are built on top of relational systems, either on mainframes or systems like Oracle or other relational databases that are inherently unscalable. So, a database like Aerospike that is inherently scalable, it can do things very much faster than the relational databases, should be potentially a replacement for those technologies. But in the industry, you see that people are very, they are hesitating to making this move. The reason for that is that these relational systems have capabilities that makes it relatively simple to build applications on top of them. If you want to move to a non-relational database, then you have to do all of these complex things that these databases are doing in the application layer. And, building a core banking system is quite difficult. Adding more complexity to it can become quite a daunting task. And then, more importantly, the correctness of this application is not going to be provable. So something like blockchain as a mathematically proven algorithm can come in to solve that complexity in the application layer and allow the banking system to scale unboundedly. So when I'm saying unboundedly, it's quite an important concept because Aerospike can scale unboundedly, but the system on top of it should be able to use unbounded technology as well. So the thing that the guys built on the Teranode project, you possibly heard the announcement that they are able to do 1 million transactions per second. This 1 million transactions per second generate around 3 million transactions per second on Aerospike database for storing the UTXOs. But 3 million transactions per second on a database is a very, very large number. But for us, it's actually quite tiny. We do have customers that do 300 million transactions per second. So yes, this guy has managed to achieve 1 million Bitcoin transactions per second, which is, I understand, is quite an achievement. But if they allocate enough resources, they should be able to do 100 million transactions per second, which is unheard of.
No, these are amazing numbers, and if you look at some of the other blockchains that are out there, and of course we don't want to get into the competitive discussion, but one of the issues is mempool clogging, and how do you deal with that, and all the standards. And I just want to come back to you on that because we talked about this, your scaling, and the scaling of impressive. But why are you being able to do that? I mean, I don't want you to give away all your secrets, but there is something that you are doing around the offloading, isn't there, on the mainframe offloading, and why is that the key? Because in a certain sense, we need to have trust in these systems to know that there is something that we've unlocked that was possible to unlock. Like what's going on today with mainframe offloading versus how you are doing it. What's the difference with a normal NoSQL standard?
Well, as I said, these systems have had lots of features built into them that is built for enterprises.
Right.
But in the past, possibly 20 years, we tried to build our systems on a distributed set of hardware that is working independently of each other, like on AWS. And mainframes are not built for that. They're a specific set of hardware. So having a technology that can work on a distributed and independent pieces of hardware, I guess that's the core. So the database world is quite mature in that space. There are lots of databases that can allow you to do that, but I guess when you start talking about millions of transactions per second, efficiencies start to become very, very important.
Yeah.
So I think in Aerospike, we are very famous for having a very efficient platform, which is, of course, very fast. One thing about efficiency is that the only way that an application can run faster is by using fewer CPU cycles, and fewer CPU cycles means faster. So I guess all of these are going hand in hand, yeah.
Sure.
Can I maybe
yeah, sure, please.
add something to that? Because it's an interesting thing you said about the mempool clogging. So this is one of the things that we had to do in Teranode to make that go at 1 million transactions a second, is to remove that mempool idea. And I'd like actually to compare it to what we had in the past, is when people invented the motor car, right? The people that had horses, they were looking for a faster horse. And that's what it feels like in the blockchain space. We're trying to scale all these things up, but we're actually not looking at what we're doing. And mempool is one very important part of that. So what we try to do is dissect what is the thing actually doing. Mm-hmm. So we don't need all these things that you normally have in a blockchain, like in the rest of these clients. You have this mempool, you have orphan mempool, you have all these kind of things. Do you actually need them, or can you strip it down to something what is actually essential and redesign the whole thing? It's still processing transactions, it's still creating blocks, but it's doing it in a different way. So I'd like to say that something like another blockchain is the horse. We're actually creating a Formula 1 car. And Aerospike is the engine in that Formula 1 car. It needs to be very, very, very fast. And if somebody from another blockchain company goes talk to Aerospike, it's like, okay, how do I fit this brilliant engine into a horse? Well, you can't. There's no point, because the problem is not the engine. There's another problem. So we're creating something that's a completely different. It's a different way of thinking about how a blockchain actually should work, and that's why we can also dissect and get to the detailed levels and use something like a key value store like Aerospike to do the things that we actually need to do, and we just skip all the rest.
So it's great that you say that because I like that analogy between other blockchains are in the horse race while you guys are in the F1 in the car race. And so Jordan, this is great, and your AWS has been providing the horse feed and also creating the tracks for the F1, right? You guys have been in the space for a long time, pre-blockchain, during the blockchain, of course, you're big in the area. So how do you see the Teranode BSV approach to this compared to some of the other players in the market that are also hosted on your infrastructure?
Yeah. No, I think to Siggy's point, right, it is very sort of a specialized approach that's being taken and boiling it down to the key elements that you're really trying to speak to.
Yeah.
And I think that's one of the unique properties when we talk about BSV and what Teranode is doing relative to other blockchains. We do support many blockchains. Oftentimes, some of the problems that we see with other blockchains or challenges are considerations around, needing to keep the entire blockchain and all of that information. So data transfer costs become problematic and challenging. Yeah. CPU and resource requirements become more challenging. And so I think by specializing Teranode and then building out the Mandala network around it that speaks to specializations while still focusing on key differentiators, it's a much more efficient and kind of optimized approach compared to other ones, which is kind of everything in one bucket. That's almost like a monolith kind of approach.
So maybe you can add something to that.
Yeah, sure. Please,
it's just the one thing that's very interesting, because you talk about that AWS is actually creating the roads for the car, and I think that's a very good analogy, because we've been working with AWS now, and they've been critical in getting us the services and the things that we need to scale up things. So we're running 6 nodes now at 1 million TPS at this moment, and it's just going great. But to scale that up, I think, if I remember correctly, it's something like 5,000 or 6,000 CPUs per node. So we're in like 30,000. Is it 30,000 CPUs that we're running?
Something like.
Yeah. So we can scale that up and down. We can get those from Aerospike. We're also using some of the shared services. And that's a very important point to make this actually viable, because they've got all the infrastructure that you need. If you're running your node on a monolithic machine somewhere, it's a very different game that you're playing. We're a transaction processor, so if we want to store all the data, all the blocks and stuff like that, we can offload them to something like S3, and this is a great service. We don't have to do that ourselves. It's very cost effective as well. So they're very key in making this happen at this.
And I think, one more thing that I noticed just in working with the Teranode project, this has taken a number of different iterations and architectures and approaches, and I think the agility that you kind of had as a result of being on AWS with managed services,
Absolutely.
Managed Kafka, all of these databases, that sort of thing, gave you the flexibility to try something, see if it worked, if not, discard and go a different path.
We were changing instance types and things up to the last minute for a test, yes.
That's great, and I'm a little conscious of all the other people in the room who are not maybe they're excited about the technology, but they really want to understand the economics of it, right? And let's go to Benjamin, a researcher here from UZ. By the way, I'm going to be in Zurich in 2 days for the 3rd anniversary of ICP, definitely, which is also trying to now do proof of work, and which brings me back to the proof of work question, because we answered that from a technical standpoint. But let's look at it economically. For enterprise, why is this debate between proof of work and proof of stake so important that they should invest in it or use that to make choices about the type of blockchain they want to use?
So I think that proof of work systems, as was also said in the introduction, I think the competition enables to run, the competition in creating these block headers enables the blockchain to function a little bit differently. And basically what we're studying at the University of Zurich is a little bit how decentralization works in proof of stake systems. And there I would just say, of course you can have centralization in like the mining power of blockchains, but on the other hand, what proof of stake systems look like, right? You have the rich getting richer because they basically have the stake, they reinvest it, and then they tend to get a better profit margin than the smaller stakers. So here I just see that proof of work is a very simple, neat solution that does its job well. That's my point of view. So
coming back on that, because centralization, and this is an interesting topic for me. I was last speaking at the Paris Blockchain, I've spoken in various places after that, but at the Paris Blockchain Summit, I was saying on stage that we all like to think the crypto natives, so to speak. That was a more crypto conference, less blockchain. We crypto natives like to think that we are decentralized, that we believe in decentralization. It's all about consensus, it's all about a network. But in fact, there is a lot of centralization at the very core of what we're doing. And how do you think this affects scalability in particular? The fact that many proof-of-stake systems and many of the blockchains and the applications that we use ultimately rely on centralized servers.
I mean, I think it's just not so attractive, right? You want to have a service that is decentralized, and then, I mean, you're claiming you are decentralized. People go on this system because they think it's decentralized, but then in fact it's not. You're interacting with a layer 2 solution that is very much centralized.
Yeah.
So I think it's not keeping all the promises there. On the other hand, I think its scalability is quite good, but then you just put trust into a very specific entity. I think that is a little bit the trade-off there.
Yeah, and I remember Vitalik was saying the other day that, oh yeah, we have some training wheels on Ethereum, and sometimes if senior developers think that something is going on, they have training wheels, i.e. backdoors, to come in and change the protocol on the fly. And I was like, okay, well, how decentralized is that, right? If a group of 4 or 5 developers can change Ethereum protocol on the fly. I'm not sure that's what he meant, but that's what it came across as. So yeah, I think this is a key issue. But another issue on the enterprise side, and those of us who've been in the space for 20, 30 years before blockchain came around, interoperability has always been an issue. We had the old discussion about monolithic systems versus what used to be called distributed systems, and then middleware and all of that. I mean, AWS has been in the middle of that. And today, when we talk about blockchain, and if you talk to a lot of tech leaders in the Web 2 space or in the standard tech enterprise, as I call them, they would say, yeah, but how interoperable is all that? If I start on one blockchain and the whole company disappears tomorrow, as has happened, by the way, billion-dollar companies have disappeared overnight, how do I move all my applications and my data, and how do I move my real-time effect of that, right? So I think this is a great panel here. So Siggi, I'm going to start with you. Interoperability, blockchain, Teranode, how do you see it?
I see it as the analogy is actually when we started the internet revolution in the 90s, and you had all these companies pop up like AOL and World Online, all these companies, and then you had the AOL network.
Yeah.
You were locked down to your AOL network, and it was great. And I think that's the same thing here. We're looking at blockchain as we have all these different blockchains, we do different things, but like you say, today we have one internet. And I think this is the vision that we see, is that you need to have one blockchain. And that's why it needs to scale so massively. This 1 million DPS is just the start. We want to go further than that. But then you get rid of that complete interoperability thing, because it's in the business where the money should be made, not on the blockchain. The blockchain should be just a basic infrastructure, like TCP/IP on the internet or something. It's the basic protocol for running your business in an honest way and more efficiently. And I think that analogy is very, very good. And that we have 6,000 or 10,000, I don't know how many blockchains we have today, it's a disaster. And with the Teranode that we're working on now, we could run all the transactions of all the blockchains that are happening today with no problem at all. And that will completely get rid of the interoperability thing. But you still don't get that centralization. You still have that proof of work. So all the miners that are operating in that space will still have to compete like crazy, but they're just all working on the same protocol, just like the internet does.
Right. And I want to take you up on that. Like the internet is, or as it was, and now it's changing.
Yeah.
AWS, you've been powering a large part of the internet as it was. And now we're moving the blockchain space. It's a different approach. How do you figure interoperability will play into that?
I think interoperability, I mean, it certainly has a place currently. You have a lot of dedicated chains that are focusing on a specific purpose, and then you need to work on interoperating between other chains. It increases sort of complexities, potential security considerations, things like that, where, in my opinion, going with something that is a established and expandable base layer that is capable of handling all of these, and then specializing beyond it, opens it up a little bit more to provide those services, kind of like what Siggi was saying. Everything can kind of go there. but at the same time still be scalable and supportive of it. So we do support multiple chains and interoperability. We also kind of add that infrastructure layer that can be kind of a common denominator between multiple chains. So if I have a database that's shared between maybe different chains and how they're leveraging it, that's a space for it. But it solves a lot of the complexities that you get with the interoperability by having an expandable sort of stable base layer.
Behrad, when it comes to databases, interoperability has been the dinosaur in the room forever. Do we make it more efficient or do we make it more open? And there have been multiple approaches to that. And when it comes to doing 300 million transactions a second, obviously you have to make choices. We all know computer science is about optimization, right? Getting the design optimal, not perfect in one or the other, but optimal. So where do you see interoperability lying, and how do you think that powers the Teranode experience?
So I guess, again, going back to the issue of scalability, interoperability, somehow working to that, it reminds me of the projects that I was involved in around 2018, 2019. Lots of financial services companies had to implement open banking solutions. And, so as we said, these banking systems that they have work on a mainframe. And, you cannot open up your mainframe to the external world because your mainframe cannot handle the external world. So everybody has started creating these basically secondary databases that hosted some of the data that was in the mainframe so people from outside can access. This was because the system, the internal system, wasn't as scalable. Again, right. The importance of a technology like Teranode that is scalable is that if you want to create something like open banking, you can just expand your system and anybody from outside can use the system that basically your core customers are using. Yeah. I guess that's the importance of scalability to interoperability.
Benjamin, do enterprises care about interoperability from an economic standpoint? Is it important in terms of when you are doing let's say a checklist of, hey, these are the blockchains I want to use? Is there an economic value to that beyond we understand the technical value of it?
I think there certainly is economic value. I think we are now in a phase where we can start to see that there are actually companies that are utilizing blockchains to create economic value. And I think the more we're moving into a Web3 direction and into the interconnectedness of everything, I think this will become more and more important. I don't know, coming back to interoperability from before, I was just thinking, there are always frictions, okay, if you create like this interoperability. I think you have to create a layer on top of another, layer on top of the other. I think there's also like, ideally everything runs on a layer that can handle everything and create a lot of data throughput, things like that. So there maybe I see the Teranode coming in because it has such a large, right? It can handle so many transactions. And then I can really see that people will start using smart contracts and then just automated market makers, DeFi.
Yeah.
I mean, you can see a lot of applications. I think they're not quite there yet, but I'm quite positive that, sooner than later we will get to that stage.
It's great that you said applications because this is where I think we've talked about the technology, the economic value, the promise. Let's sort of bring it down to real examples that people can touch. Applications. To me, as a crypto native, ordinals is one space where I think Teranode and the BSV chain can be very useful. And it's kind of, I think, what the ordinals guys, what Casey and the group are trying to do. But that's not the only one. But maybe you can shed some light on where do you guys see the focus, including with ordinals?
Well, I'd like to not answer your question.
Okay.
And say it a little bit differently. What we were focusing on is creating an open chain where anybody can do whatever they want. So you want to do ordinals, you want to do different types of tokens, you want to do smart contracts, you want to do DeFi, it doesn't matter. But the idea that has been talked about for a long time, is the idea of spam transactions, is something that we don't recognize.
Right.
If you're paying a fee, I will take your transaction, I will put it into a block, and I will take your money. So it doesn't matter what you're doing. So where this is going, I think we need to create something where the creativity of the market can actually flourish and people can do crazy things like ordinals, came out of nothing, that's fantastic, and not hamper the growth of that. I remember the first thing that came out was the CryptoKitties NFT some years ago, and it was amazing explosion of activity, and it just died down because the network couldn't handle it.
Yeah.
That's what we don't want. We want people to be able to create businesses, put up crazy ideas out there, and do whatever they want on the blockchain, and we will ingest all of it. That's our goal.
So that's an interesting approach, because what you're saying is essentially, I'm neutral to the type of application.
Yes.
I'm neutral to the business model you want to have. I'm going to provide you a neutral, very fast, scalable, efficient transaction machine,
Yes.
and then you do what you want with it, right? Which is interesting, because that's not how a lot of the Bitcoin community looks at it today. They look at it as it's meant to change the financial space, it's meant to change how we see money and governance and politics, but not really for CryptoKitties or now for ordinals. On Amazon, I know you guys have some of the biggest blockchains in the world and you see a lot of application spaces happening. Where do you see the market pushing, especially on the enterprise side, because you've got that side of the touch point as well?
Yeah. No, I think at Amazon, one of the big, certainly we speak to things like DeFi and considerations around that, because that is kind of where the visibility is right now. But data integrity and attestation is a huge consideration, especially with AI being such a big component of things. So having an expandable blockchain that can provide that data integrity based on people's needs of storing data or being able to prove the validity of the data, I think is one of the big opportunities that things are really focusing on right now. There's a big push for AI/ML, but the data that needs to go into it needs to have qualification, and that's where an unbounded space and data handling sort of comes into play.
Behrad, 300 million transactions a second, but there are applications that may need that, others that don't need that, but that might not be how the market views it, right? And when it comes to applications and blockchain, I always feel that the market has its own view on what is important compared to what we as technologists always thought was important, right? What are you seeing in terms of key application services that would be using your database or using the Teranode F1 and your engine on it?
Yeah, there's another concept in scalability that is called elasticity. And it means that can you basically wind down the amount of resources you can do and basically increase the amount of resources to be able to do more. And I guess that's quite important in terms of the application. So yes, you're right, it's unlikely that in the next couple of years we need to do millions of transactions or hundreds of millions of transactions. But again, we do have customers that do 300 million requests per second. But many of our customers are only doing 5,000-6,000 transactions per second. The possibility that you can efficiently go to millions of transactions, hundreds of millions of transactions, that's the importance and the application of an infrastructure like that. And again, this elasticity is built into Aerospike, and this elasticity is built into the Teranode project as well. So you don't need to start with with a network that can handle 1 million transactions per second. You can start with a system that can only handle 50,000 transactions per second. And as required, you can increase the amount of resources and linearly see that your system can handle more transactions.
Benjamin, do we see some applications being more favored by the market because of the immediate or the short-term economic value of them versus others that impacts how enterprises might or might not adopt a scaling platform like Teranode?
Well, I think there are simply some applications that are not... When it was said that we don't see millions of transactions right in the near future, I agree, okay? I tend to be not so optimistic that we will see millions of transactions in the near future. But I think there are some applications that we did not yet think about, okay? And that will come, and at that point when everybody onboards them, and I don't know, it might be also related, I don't want to be too speculative, but like with AI, you have a lot of data questions, you want to have a lot of requests, you want to have them verified, you want to maybe know if it's like, if it's done by a human or by an AI agent, things like that. I can imagine that then suddenly there will be a huge spike in like the demand for how many transactions can you do and how scalable the blockchain is. And so I'm just saying it might be more sudden than we think.
We're almost at the end of our time. So let's do a wrap up in terms of our closing. You know, what's your final thoughts on it? We'll start with you this time, Benjamin. What's a final thought that you might have to share with the audience, or a final insight that we might think about as we move on from the panel?
I think that really scalability is a key issue for all blockchain applications. I think with scalability, there comes like the transactions become cheap, and hence any economic player will want to have this, right? So your business will be as good as your data structure will be. So you want to have a scalable blockchain. I think that will be the future. I'm not sure how this will be achieved, but I think there are solutions, and we can see one of them here, I guess.
Behrad.
So, as I said in the beginning, I'm not a crypto expert, but I studied cryptography in university a long time ago. So, I've heard of Bitcoin when it came out. So, but I never bought any Bitcoin. Bad mistake, but anyway, so I've never been into it because I've always thinking that, well, it is actually not solving a problem that we are not able to solve with other technologies. But the importance of this project, again, I'm reiterating the thing that I said many times in this talk, this is the scalability. The scalability of a banking system, of a core banking system, I don't know, I've never heard anybody done that properly. And this system is capable of doing that. And that's quite a unique thing. And as I said at the beginning, we in Aerospike, we are very proud of being part of this project.
Don't worry about not buying Bitcoin. I have a token I want to sell you, yeah? Jordan, with all of the visibility you have into the market and all that, I'd love to hear some closing thoughts from you, some insights about where this is all going.
Yeah, in my opinion, Teranode is beneficial because it unlocks the scalability, but really it's kind of a keystone for people who are building on AWS applications and our customers to really start expanding as part of the Mandala network and building things outside of Teranode. The applications that they deploy and the services they provide to their customers are enhanced by this kind of foundational layer. But really, it's going to open up the capabilities for people who are building on AWS as they start leveraging kind of this new technology.
And finally, Siggi, as the creator of Teranode, what are your final thoughts for us?
To follow up a little bit what Benjamin said, we don't need these transactions today. We know that. Nobody's doing 1 million transactions tomorrow, but it's going to come very fast. But what we're doing, we're trying to show to the world that the stories that have been told over the last 15 years are just not true. A UTXO-based proof-of-work blockchain can scale. And 1 million transactions a second is an insane, it's a mind-boggling number, it's an insane thing to do, but we did it. And it does work, and we can do it. And so I think the message from that is, go out and build great applications, and we will support you. We will, build the rails, and the roads, the Formula One car that you can then sit in and you have your application scale, and we'll be there to support you.
Yeah, I actually love that analogy of, let's build a Formula One car for blockchain and make sure that you can take it off and do crazy things with it. You've been a wonderful audience. Thank you very much. Thank you to the Extreme panel, and enjoy the rest of the London Blockchain Conference.